When an equation contains fractions, it is possible to solve that equation like normal using inverse operations. In this first case, I could just subtract 1/9 from both sides and then divide both sides of the equation by 2/9. However, this strategy is really error-prone. Students make a lot of mistakes when they're adding, subtracting, multiplying, and dividing by fractions. In algebra, then, we expect you to use a different strategy, a strategy of clearing fractions. What this means is you are going to rewrite your equation so that it no longer contains fractions and then solve using inverse operations. To do this, each term needs to share a common denominator, and then you can multiply both the left and the right-hand side of the equation by that common denominator so that you no longer have fractions. This first example is great because each term already has a common denominator. Each term already has a denominator of 9. That means I can skip step 1 and go right to step 2, where I clear the fractions by multiplying both sides of the equation by that common denominator of 9. It's okay to show your work this way, times 9 times 9, but it's more common to show that multiplication using parentheses. So parentheses around the left-hand side times 9, parentheses around the right-hand side times 9. This helps make sure that you remember that you're multiplying each term by the common denominator, not just one of the terms. So 2/9 x is the same as 2x over 9. If it helps you, you can go ahead and write that x in the numerator. The x is in the numerator. So 2/9 x times 9 is the same as 2x divided by 9 times 9. 2x divided by 9 times 9 is just 2x. 1/9 times 9 is the same as 1 divided by 9 times 9. All I'm left with is 1. On the right-hand side, 5/9 times 9 is 5 divided by 9 times 9, which is 5. The effect here was to just cross out the denominator, leaving only the numerator, which gives me a great fractionless equation. However, you can't just cross out the denominator. You have to show me why that has happened. You have to justify that by showing the reason there are no longer any fractions is because I've multiplied both the left and the right-hand side by 9. Now I'm just going to solve my easy two-step equation using inverse operations like always. First subtracting 1 from both sides, and then dividing by 2. So I have my solution, x equals 2. Much nicer to solve 2x plus 1 equals 5 than 2/9 x plus 1/9 equals 5/9.